we are using at the site. So the problem that this is intended to address involves something that most sites that use AFS, if they start to become very large, so at the beginning when you use AFS, you might use it, in one group. One group might start using it, just trying it out, and it may grow to other other departments in the organization or other units, places that are in different places, different geographic places. So as it grows, you start to get clients and maybe file servers and other AFS using things that are very geographically diverse, very far apart from each other. So you may have, so even if you have one AFS cell, you still may organizationally have a department, a different building that you think about, but they all use one cell. It's all one logical environment. So so many times you'll start to encounter certain limitations which make this very annoying to use, very painful. One of them is the 13 replication site limit. So the VLDB can only define 13 sites in one group. So if you want to have redundancy, of course, you can have multiple read-only sites for a volume. But if you want to have a volume in, if you want to have a site in New York that's able to access this data, and in California, and in Texas, and in Sweden, and in all these other places, if you want to have some replication, some redundancy in each of those spots, you might want 2 or 3 sites at each of those locations. And then if you have 10 locations, you can't have 3 sites at each of those, because that's more of the sites than we are able to currently support in the VLDB. Well, I say VLDB, it's not just the VLDB limitation, it's the protocol limitation as well, serving things to clients. Another annoyance is that the regions, if you have separate regions like that using the same cell, the regions are not isolated from each other. If you have all the file servers in one region go down, the other clients typically they'll prefer the file servers that are close to them. But if all of those are down, they'll go to another region to grab the data, and if it's very far away, that'll be slow. It'll impact the other regions. In addition, the database servers are, if you have one cell, you have one set of database servers. If they become broken or unusable in some way, or just become slow, then that impacts everybody. That impacts the entire installation. Well, yeah, and I just said that cross-region access is just slow in general. Releases, also doing volume releases, tends to be slow because you're far away. It's just very annoying. So there are actually a few different approaches to get around this. One that we had seen attempted at a site before we had interacted with them was making multiple copies of the same volume that had different names according to the region that they were in. So if you have a volume that contains the code for, say, GCC, I mean, it would be versioned, there's usually more stuff in there. But you would have a master copy called, say, app.gcc, and you would make copies of that volume for say, the North American region or the Europe region, and maybe others as well. And each client in one of those regions, so if you had a client in the North American region, you would have a symlink, say /app, which would point into AFS and inside a volume inside of there, and all of the volume mount points under that would be pointing to app.gcc.ma and app.whatever.ma and so on and so forth. It kind of worked for a while. I'll give them some credit. It is pretty cumbersome to need to modify the data in the volume. So when you do this, if you have volumes that refer to other volumes, so in the master copy, you might have a volume that has a mount point for app.gcc. But when you copy that volume to another region, that mount point needs to change. It needs to point to the NA version of it, not the master version. So when you release a volume like this, when you update it, they had something where they would go into the dump stream and modify what the mount points were before before updating the other copies of the volume. And in addition, because we're still only using one cell, we have multiple copies of some of the data, the DB servers are still shared amongst all the regions, and so we still have all the same problems with the database servers that we had originally. So it doesn't solve that. Another idea that has been tossed around, I don't think we've never implemented it, I don't know of anybody that does use this, is the idea of a split horizon VLDB. analogous to split horizon DNS. So if you had a VL server and you have a client that asks for a volume, you wanted that client needs to know where that volume resides. If you have one client ask for that information, the VL server could respond servers ABC. And if a different client asks for that information, you could respond with a different set of servers. So you could have a certain set of servers that are file servers that are considered part of the NA region, for example, and another one that's for the Europe region. And if a client is from the NA region asks for this information, it would only get the NA servers back. Nothing in OpenAFS right now does anything like this. So there'd be a lot of new code to do this, a lot of new documentation and procedures, and it's just in general, I think, very confusing. Split horizon stuff, like even not in AFS, it's just kind of, it looks kind of weird because you get different results from the same query, and that's potentially rather confusing. You also need to define the regions. You need to define, you need to have some way of defining if a client is in region NA, EU, or so on and so forth. So you might need to define like IP ranges or something, or you could just have something on the clients themselves, but the VL server needs to identify what they are when the request comes. So that's another administrative responsibility. It's a little annoying. And again, in this situation, we still only have one cell, so the database servers still have all the same problems. You can kind of do something similar if you specify different cell serve DB entries for the same cell name. So you have subsets of certain clients that go to different DB servers. That has the same issues with this. It's confusing and it's not super great. But I've never actually tried to run it, so I don't know. The approach that we took at one site that was having that kind of had the first approach that I described. The approach we ended up taking, which I think is the only approach I've seen last that people use for a long period of time, is the idea of having multiple cells, and each cell is used for just that one region or that business unit or whatnot. So the general model that these tend to follow is that you have a master copy of a volume in a cell, like a source cell or a master cell, and then after you release it in that cell, you dump it to all the other cells that you want it to go to, and you issue a local boss release in those. This has the advantage, of course, that the number of sites you have is now unlimited. You have n sites if you just want more sites. If you want more, if you want it to be in more regions, you just define more cells. There's no limit on that because the cells aren't aware of each other's existence. All of the regions are completely isolated because they don't know that they don't need to know that the other cells exist at all for the clients, for the non-administrative portions. And a lot of the OpenAFS tooling, of course, already fits this model because most of the pieces only need to really be aware of their current cell. So nothing needs to be updated. You don't need to mess with anything when doing releases and all that stuff. So many places will have their own. So I'm aware of a few places that did something that have this multiple cell this setup, and in order to do the administration for it, so the thing is, I said it fits a lot of the models. The model fits a lot of the tools in OpenAFS, but the main thing that's missing is the administrative tooling, the release process. There's nothing in OpenAFS that really talks to multiple cells for administration. So a lot of places will write their own tooling on top of OpenAFS to manage the different cells and handle the release process between them. And up until we did this, they were all internal only projects and proprietary, and you're not even allowed to say the name of them. You're not allowed to advertise them, and so you can't. It's a lot of reinventing the same thing. So we tried to get this site to use something that we could release publicly and be open, and they agreed to that. So the tool we have that we created for this was called CellCC for cell carbon copy. It's something written in Perl, uses MySQL for some data storage, and uses primarily run control for communicating between, for a direct point-to-point connection between servers for volume transfer. One of the goals of this is during the transfer process, we try to have retriable, very discretely defined steps that are idempotent. And so if something fails, you can just restart at the last known good point, like the last checkpoint, and you just redo that operation. And it's like doing an operation twice doesn't change anything instead of doing it once. So, and by steps, I mean, our steps are typically something like you have to dump the volume, you have to transfer it to the other remote area, and then in the remote area, you have to restore it to a server and then run the local boss release process. The software is a bit distributed. You need to run pieces on each of the source cells and destination cells. There's one server that's kind of centralized that checks everything and restarts things that have failed and can retry. I actually wish it was a little more centralized. It's annoying to have to install all these pieces on all these different servers, but this was somewhat unavoidable, at least in the case of this site, because a lot of there was no good spot to have one server communicate with everybody because of firewall rules and things like that. They don't allow direct connections between all of the points that we required. The code for this is deployed in production at that one site. It's been there for a while, years now, I think. They seem to be, he's pretty happy with it. There's one main guy that we talked to that runs this. But it's important to know this is, this piece of software is not full lifecycle management. The sites that do this multiple cell stuff often have a much bigger piece of software which handles not only the synchronization between cells, but it handles a lot of things like access, delegated access rights, and keeping track of when things are allowed to be retired, and a whole bunch of other stuff. It's much more high level. So all we're trying to do with this is solve that one piece of having kind of an extended boss release. You just go from cell A to cell B, and there's some other features, but that's the primary goal of what we're trying to do. So I said it was kind of distributed. There's several pieces that you run. This is just an example of what they kind of look like. So to start a sync from a source cell, you run that command, CellCC start sync, and you give the cell name of the master cell, the source cell that you're synchronizing from, and the volume name. You note there are no destination cells. We don't say where it's going to. That is instead part of the configuration. So the configuration says for various cells, this is where they go. On the cell that is, on this source side of things, somewhere in the source cell, you have to be running this daemon, which we call dump server. And the arguments there, there's 3 arguments, or sorry, there's at least 2 arguments. The first one is the source cell, so the master version, the place where we're dumping from, and all the arguments after that are the places we're dumping to. So the same daemon process can handle the dumps for multiple different destination cells, because it's more convenient to do that because we can reuse the dump file. We obviously don't want to dump it multiple times if we don't have to. And you might wonder, and the reason why we define different destination cells is because you may want to have the dump server running on different machines, depending on where the destination cell is. So if you have a cell, if you just have a North American cell, you may have file servers in New York and California, and you may be synchronizing to a Europe cell and a Asia Pacific region cell. So when doing that, you may want to synchronize from the file server in New York to go to Europe, and you may want to synchronize from the file servers in California to go to Asia Pacific. So that's why you can define multiple different dump servers for the same source cell going to 2 different destinations. On the other side, on the receive side, on the destinations, we have a daemon process called the restore server, which is the machine that we transfer the dump to, and that's the one that handles the boss restore and the boss release process. And in addition, we have something that we call the check server, which periodically just looks at the jobs that are running and checks if they need to be restarted. It handles some reporting and logging and things like that as well. Things that are kind of global to the entire environment. We have some options in here for controlling where volumes go and how they are distributed. It's not terribly complicated, but there was a couple of features that the site wanted added to this to help them control the process. So the first thing is this idea of queues. The volume release processes can be defined into different queues. And the reason why we do that is so we can use different settings. We use different subsets of the configuration that apply to different volumes. So that's how we define that. So the parallelism we can change depending on the queue, which is important for them because when they release certain volumes, they will depend, some volumes will depend on others, like some applications will depend on another application, and they have a reference, they have like a mount point in there that refers to the other volume. So when you have a volume like that, you need to release the dependent volume before the parent one, otherwise you'll have a mount point inside the volume that won't go anywhere because it won't exist in the target cell when you distribute it to that cell. And we don't handle, like the CellCC itself doesn't handle any like dependency checking or something like that. But the way that they handle that is they're able, the thing that calls us to do the releases handles that dependency on its own. But it needs to make sure that when we do that, it does, like if you're releasing like 10 volumes in parallel, that means if you do one before the other, it's not a guarantee that you'll actually be finished before the other one starts distributing to that cell. So for some of their volumes, they need the parallelism to just be one. We can only run one in parallel. So they can do things in order, and they're guaranteed that they actually run in that order. Another thing that we want to specify between different types of volumes are the flags that's given to ROS for release. Right now, I think we just do releases, but we could add it in the future where you could give different flags to dump and restore. For this site in particular, they wanted that for the specifically for the DPF feature, so we could use the DPF mechanism for the releases on some volumes, but not others, because they were like testing it for a while. We also have this hook that I call the volume filter. It's an external command that we run that is used to say if we actually should synchronize this volume from the source cell to this destination cell. The very crude way of doing it, so you could just not call the start sync mechanism to avoid synchronizing the volume for that, but they wanted an extra. I'm not sure exactly what they do in here, but they wanted another command to like check a database or check some other configuration to see if a volume should actually go to the cell that we specify. So we have some progress reporting on like how a transfer is proceeding. So this is an example of, so the command is CellCC jobs, and it prints out a whole bunch of information on all the jobs. This is just for one. So you get to see the volume, the source cell, the destination. The DV is something you can use to track if something has changed. So every time we do something with it, the DV increments. What queue it's for. So this queue is for app. So you may have just examples of queues I didn't mention. So you can have like application volumes, volumes that store configuration data, volumes that just store like symlinks, pointers to specific versions of what you want to use for those volumes. We record what state, like which step we are in the process of doing stuff, how many errors, because we can encounter errors and retry. So this particular job has had one error, so it was retried and it's continuing now. You get some timestamps of when it started, the last time it was touched, and this idea of a timeout. So if a particular step takes too long, then we consider that an error, and we just kill it and we restart the process because something appears to have gotten stuck. You also see how big the dump is for the dump that we're doing after we have that information, and you can see the last time anybody, like any server did something with this job, made progress on it, so you can see which host it was and what it was doing, like the last thing it was doing. So if something gets stuck or if it dies, you see this is the last thing that it did successfully. And since I mentioned that we can encounter errors, of course, sometimes we encounter errors that we can retry. There's a limit to how many times we retry. So if you encounter too many errors, like the job will just fail, and of course we want to report that somewhere. The sync process is kind of asynchronous, so there's no, you can't just print a message to standard error or something like that. There's no process, there's no place to print that to. So we have these alerts that we can send out. So that one there is for a job that encountered an error but was retried. So it may be okay. It's configurable whether or not you actually even see these or not, because you may not care because it's not a fatal error. It's just it's kind of a warning. And there's a few others. The other main one, of course, is if a job fails because it encountered too many errors and hit the limit. There's some others, I kind of forget what they are. I think there's some if the job takes too long and other stuff like that. So this text we generate, this can either just go into a log file. It can be passed to a command, which you would typically use to send an email, like an alert to somebody. I think the text I have here is the default like text renderer, but we also provide a way to get it in a machine readable format in like JSON, so you can parse them, you can format the message however you want, or have it go to like other machine readable mechanisms or anything like that. So one thing that you might think about when I am talking about all this stuff that we wrote on top of OpenAFS, to have this, we think of CellCC as like an extended BOS release. So you release one place, then you synchronize it somewhere else and just run the release over there. So couldn't we just make BOS release do all this stuff itself? When we were talking with this site about their solutions to this, that was immediately shot down because of the performance of BOS release over large distances at the time. This was before any of the DPF stuff. So they really wanted something that used something else. So we used rem control as our transport mechanism here, and he's pretty happy with how fast that goes. That's a little more reasonable. But it always, I never forgot about the idea of just trying to make BOS release do that, because all of the logic in a volume release is inside the BOS binary. The volume server itself is really like a dumb part of it. It just does it just shoves the bytes over the wire, and it pushes the data where you tell it to. So we could have BOS just tell it to push the volume data to a file server in another cell. The main piece that's missing from this is that when the volume server does that, it uses the authentication information that it has in its own local auth key in its key file, or key file X to keep. So if we're talking to another cell, if they use a different cell-like key, we won't be able to do that. If you use the same cell-like key, I'm pretty sure we could do this if we just modified BOS release to do this.
But your security auditors hopefully would complain at you.
Well, it depends. I mean, sometimes these regions are like different racks, like they're in different rooms in the building. So there's not necessarily any security. Like security is one of the things you can get from that security isolation, but it may not be able. But if we added a way somewhere in like either the protocol or the local configuration on the volume servers themselves or something to allow alternate keys to be used for forwarding to other machines, it seems like that could possibly work. I'm not aware of a reason why that would not, but I haven't tried to think it through all the way. The only concerns, downsides of that, it would be the first thing I'm aware of that does administrative operations in OpenAFS tools that is like cross-cell. Pretty much everything has this idea of one central cell, and it's kind of a new thing for things to be doing. Some user utilities, obviously, the client is aware of multiple cells because you can have tokens for different cells, but all the admin stuff is really just like the cell is one isolated unit, and this would make AFS kind of go one level higher and be like a multi-cell management system, which is some people might argue is not really what it should be. In addition, the BOS release code is really complicated, and it has these complex structures that are all managed in C, and I really hate touching it, and it always makes me nervous when we do anything with it. So adding something like this would be, or adding something similar to the BOS release process that would work across cells seems like it's going to be a lot of work. Writing it as like a tooling on top of OpenAFS in a different, like a higher level language is a little more appealing from a development point of view. Of course, we could also just sometime maybe replace BOS release with something that's written something else. I don't know. So the code is there on GitHub, so it's not part of the OpenAFS project. It's its own separate contribution. It's primarily myself and Marcio that make changes to this. But if any other site wants to use it, that would be fantastic. We would solve bugs for you very quickly. We would be very enthusiastic about helping you with it. And slides are there. Okay. Any comments or questions? Yes.
So with the with the BOS dump and the BOS restore and the BOS release, you guys take care of the data version issue that's out there with the volume, with the directories.
The data version issue?
Yeah.
I'm not aware of what you're talking about.
That's something that back in, Paul and I were talking about it at lunch today, when anytime the boss, the data version of the directories, how it gets updated during certain boss transactions or something like that, either whether boss dump or boss restore or boss release, and somehow as you have the two different cells, if anything else is happening on the other cell where they might be doing updates and doing boss releases that are different than what's going in the main cell, the data versions can get
so Todd is asking about in the remote cells if there are other modifications that happen when we do the release. How does that can interfere with the process? And yes, and that's true. So the site that we run this on takes great care to make sure there are no changes done on the remote sites. So we either there's a file server option for read-only where it rejects all write RPCs, so you can't write to anything on the file server, or you can offline all the read-write volumes to make sure that nobody ever makes any changes to them. That's something along those lines is how they try to address that. So you don't have changes in the remote cells. They're read-only only.
Right, because what would end up happening is once you do the release to the other cell, that
the DV, the data could be different, but the DV would be the same. So the cache coherency would be
right. So even though it's the new volume and the data is cached on the client, even though the data really is new, when it checks its data version, it sees that it's the same, so it doesn't, refetch the data.
Yeah, so it is very important to keep the remote cells so they're not modified by any other means, and that's a limitation. It's something that you have to try hard to make sure does not happen. There was another issue I was aware of. There was an issue at another site where they did some monkeying with the DVs manually. I don't really remember why, but that was a problem we had where they modified the DVs to be a timestamp for some reason. In the past.
That's what we figured out for
But that's because they modified the DVs to do that, and that was that's unusual.
Right, but without doing it, it caused lots of failures and lots of problems at that company's site. Yeah.
Oh, okay. You're saying that was done to avoid the issue that we're talking about here.
That was, yes, because every time you took the boss dump, you would take it through that utility that would update the data version to the current.
Okay, because I was thinking of a case where it caused this problem because they had some volumes that did that, and I thought they someplace had stopped doing that. So they had some volumes with DVs that were really, really high, and you had the same volume at a different cell where it was lower. And so if it got incremented just over the course of using it, and it eventually became equal to that number, then that caused exactly the same problem. The DVs becoming equal.
Right. So as having the data version be the time that basically either the dump was taken or when you're running that utility, and then you're pushing that out to all the satellite cells.
Yeah. So we could do that. We don't do anything like that here. We don't mess with the volume stream.
That is the. So if you ever hear them complaining that, we did the boss release, I'm still looking at the old data or something like that, that'll be the reason.
Yes.
One of the potential reasons that they're not getting when we had the top of the conference here a few years ago, here the last time, Phil was talking about, this issue.
Mm-hmm.
Phil was talking about it.
Yes. What are your thoughts on or your observations on how much parallelism can be allowed? How many boss restore and releases could you be running at the same time?
Okay, Paul's asking about how much parallelism is or what's a good level of parallelism, how much we can see for running restores on the remote cells. So I don't know. So the settings they run with is typical. So we have these different queues, and each one has a different amount of parallelism. I think they define up to maybe 10 or 20, but there's 5 different queues. So each one can be parallel from the other queues. So I'm assuming their max is probably around 20 to 50, but I don't know if they actually hit that. And at least, so the guy running it hasn't complained about that. Hasn't complained about it being too slow or anything like that. For the most part, he probably does not care about how fast it goes, that last step. So that's why we haven't heard complaints, but we haven't done any exploration like tuning or performance analysis for that or anything like that.
When we're populating new cells and we have to put 3 million volumes into an existing one, we'll do just basically, don't restore every partition on the source cell to every partition on every server on the destination cell. And I think Paul's question was, after we do that, we find like several thousand volumes didn't make it for some reason or another. Right? And then so it's like an iterative process where people have to do 6 or 7 times, and there's still a few that you have to do by hand, because we're not doing any of the transactional integrity or checking that you're doing. But I guess the question is really, do you think you can handle the throughput of moving 3 million volumes? Like, how long would that take?
I have no idea. Yeah, I haven't looked at it. I'm not sure. I mean, the main bottleneck there probably is it's the boss restore process, the boss restore and boss release process, the intermediate steps of transferring things to the target destination, to the destination cell. I can't imagine that would be a bottleneck or a problem. So that's most of what our code does is involved in that transfer. Yeah, the other bits are they're left to OpenAFS. So this is me seeing this is me talking from my perspective as like a developer using this tool on top of OpenAFS. That stuff is all OpenAFS's problem. And then of course come over here and I say, okay, now as an OpenAFS person, yeah, I don't know.
Well, with volume server would have a limited number of threads, right? So it can only do so many parallel transactions at once. Is that what they're saying?
Well, I think they're saying it just fails, and we don't know why.
We don't know why, and we haven't looked into the details. Yeah, that is true. You do have a limited number of threads, so there's only so many transactions you can even do in parallel.
I think what happens is there's some weird problems that occur when there's many, many restores going on. And if anything happens and one of those restore transactions gets in a bad state, it can remain hanging and not time out, not die cleanly. So then you get a partial restored volume.
Yeah, so I mean, that's the case where obviously you restart it and you should restore the whole thing, and that should correct it, but if it's hanging, obviously it won't. If I remember right, there's an issue with your backend storage possibly hanging as well. I don't know if that's relevant. Don't want to blame it on that. But.
Yeah.
So do all the customers who do this kind of thing have the PTS IDs always the same in all their cells, or is there some way to intercept the data and then translate?
So I can't speak for all of them, but at this place, yeah, they synchronize the protection database between cells. So that's when that's a piece I didn't talk about because it's not about CellCC, but it is relevant to the multi-cell management. Is that tool I mentioned in passing before? The question is about synchronizing protection database IDs between the cells if we synchronize them or somehow intercept and change them or whatever. So there's that tool I mentioned in passing called UBIC-CP, which is able to read a database from a running database server. So periodically they would just pull the running protection database from the server and then transmit it to the remote sites and install it there. There are, the term of who's running it. So some places will just they'll stop the servers, put in the new database and start it up. There is another UBIC-CP command which can write a database to a running database server. I don't think they're running that, but I don't remember which they do.
In our case, there'd be no way we could ever get all the different cells to standardize. So we have to intercept and translate the PTS IDs.
So you recognize what the ID is in the source and you see which cell it's going to, and you have a mapping.
You have to have a mapping, or you have to drop it. So you have a mapping that your group.
Oh, yeah. So if that group didn't exist in that cell, you would remove it from the ACL.
I suppose. As well as could then create one and then get access, right? We wouldn't know.
But these cells that you're talking about probably have different users and different cells. They have different volumes, different data sets that are parallel. So they wouldn't be copying.
For many things, but then there's some sets of customers who are common, but they've created groups that have different PTS IDs and the different cells because that's what they got at the time. And they can't get them and say someone else owns the PTS ID they had in this cell when they created the same group name the next cell.
Yeah. So I think in this case, this is the users in this case don't they don't modify their own group memberships themselves. They have some other system they go through for that. So all the modifications also happen only in the master cell. I think there's a flag to the PT server which he reported a bug for because it was broken. There's a flag to the PT server to prevent people from creating groups or creating their own groups or adding people to groups, which also prevents changes from happening in the remote cells. So they have some system where the users have to request changes or access changes or whatever, and those go through all the master cells. So that's how they're addressing that.
Maybe I should talk to you later. I'm
What's
curious. Maybe I should talk to you later. I'm curious how we could use it in some of our cells, but it would be very specific to how we're set up.
Well, I mean, so you're asking that question, are you doing anything right now, synchronizing
The
things?
customers do it out of band through, they have rsync through pipes, you know.
Yeah, so it is possible to have a step in the process where you do a translation from the source cell to the destination cell. We've done, like, there's tools to interpret volume dumps. And there is another site that does the not the site that uses this, but another site that does the cross-cell stuff. They need to, they have some mount points that refer to the current cell by a fully qualified name. So the mount point, like, so if your current cell is, you know, like master.example.com, they would have a mount point in there that said master.example.com : app.whatever. So when they synchronize that volume to another remote cell, they need to change those mount points in the dump stream when it gets to that cell. So you could have a similar step for something like protection IDs that interprets the dump stream and modifies it. But yeah, getting that mapping from source to destination, like you'd need some kind of management, something that would get that information. I'm not exactly sure how you do it. Because if it's not managed already, like where the master cell knows what they all are in the destination, that's the trouble. We don't know what it's supposed to be. I think also at this cell in particular, access controls to the volumes is not as important. Most things are readable by anybody. Okay, anything else?
Thank you.
Sure,
Matt?
yeah, but you said you don't like to write things as complex as false restore in C, like a high-level language instead. So what's your favorite high-level?
Most of the stuff I do now is Python. I don't know if I'd say it's I don't know. I can hear Tom Kaiser like screaming from that Python has all these problems and such. And, I don't know enough to really say that like, oh, I love it or something like that. But it's the thing. So previously, the choice would be Perl because it was everywhere. Now Python is becoming everywhere enough for our purposes. So that's what I tend to use. I'm not enough, like I don't advocate specifically for it or anything like that. But this tool is in Perl, and just anything that can do like hashes without having to write our own hash every single time, and just the memory management for it is very nice. Thank you, Ben.
Any other questions for Andrew? Thank you.
Thanks.